This is section 2.2 in college algebra, solving linear equations. And we're going to look at different ways to solve linear equations. Symbolically is the first way, and that's probably the most common way that you would think to do it, and that's just solve it algebraically, what you're used to doing. So let's look at an example. If you were asked to solve 3 times x minus 4 equals 2x minus 1, you would distribute the 3, and that would give you 3x minus 12. Then you would subtract the 2x so that you could get your x's together, and that would leave you x minus 12 equals negative 1. Then you would add 12 to both sides to get that on the other side, and then you would have your answer. You'd be left with x equals 11. So that would be solving it symbolically. Another example would be x over 3 plus 1 equals 2/3. When you have fractions, you want to get rid of the common denominator. So the common denominator is 3 in this case because it's the only denominator we have. And to get rid of it, we want to multiply by 3 over 1 at every piece of the equation. So when you do that here, that 3 and that 3 cancel out. Over here, that 3 and that 3 cancel out. So here you're left with x plus 3 equals 2. That makes it much easier to look at, much easier to work with. We're going to subtract 3 from both sides, and we're left with x equals negative 1. So that's just a couple of examples about solving symbolically, which you're used to doing, and we will do some more of that. Now, solving graphically. And you can use your graphing calculator to do this. We will certainly do that. Set y1 equal to the left side and y2 equal to the right side of the equation. That's step 1. Graph them in the same plane, and you find the intersection point. The x coordinates are the solutions to the equation. All right, so we're going to practice that. Solve 2x minus 1 equals 1/2 x plus 2 graphically. So in your calculator, and these are screens from, let's see, let's just go here. I want to turn that off again. Oops. All right, let's go to y equals. Let's clear that, and let's turn this plot off. All right, so in y1 we would put 2x minus 1, and in y2, let's use 0.5. It's easier than writing that fraction out. 0.5x plus 2. All right, so we've got our two equations in, and we'll do a zoom 6 because I had changed the window, and zoom 6 gives us a nice standard window. So you can see that that's that picture that I have there. And here's the 2x minus 1, and here's the 1/2 x plus 2. We're supposed to find where these intersect. All right, you can do second calc, number 5, and we will hit enter 3 times. 1, 2, 3. And it tells me the intersection is 2, 3. All right, and so the solution for that, as it said in that graphing, the table above here, the solution, whoops, need that, is the x coordinate. So if our intersection point is 2, 3, the solution would be x equals 2. That would solve that equation. The numerical solutions, you're actually using a table of values for that. And so let's look at this one. Solve square root of 3 times 2x minus pi plus 1/3 x equals 0. That'd be kind of crazy to try to solve right now. But if we go to our y1 in our calculator and put that in just like it is, what we're looking for, then we're going to go to our table, second table. So let's just look at a couple of things. Here's where the table is above graph. So when you go to second table, That's there, and actually my information is still there from the other where I started that. But anyway, second table is where you want to go. And when you put that in, you want to first off start in increments of 1. And I guess I actually need to just put this equation in to show you. So let me clear this. Okay, so I got the equation in, and now I've gone to the second table set, which is above window. And you want to start at 0 for the first part to look at this. So we're going to start at 0, and it says to go in increments of 1. That would be here. This is your increments right here. So we're going to put 1. And you want both of those on auto. So now we're good, and we'll go to second table. We should get what I have here. All right. So what you're looking for is, where did that change from positive to negative or negative to positive? Well, at 1, I'm at a negative value, and 2, I'm at a positive value. All right. So now I know that it's between 1 and 2. My solution's between 1 and 2. So when I go back in to my table and go to second table set, now I'm going to start at 1, and I'm going to go in increments, because I know I'm between 1 and 2. I'm going to do increments of 0.1. All right, so second, and hit my, I want to get a second end table. All right, so now I am looking for, and you can see it right here, there's negative, there's positive. So now I know I'm between 1.4 and 1.5. And I could do it one more time, and I could start at 1.4 and do increments of 0.01, and I get that it's between 1.43 and 1.44. And so I think the solution is 1.4. I think the problem actually said round to the 10th, so it would be 1.4. And if you found the x-intercept for that equation on the calculator anyway, it would be 1.4. So that's another way to do that. All right, let's look at our problems. All right, solve this with the intersection of graphs, and we'll put this in y1 and this in y2. So you can see a screenshot of me doing it on the calculator. Y1 was 4x minus, that's covered up, minus 2.1, and 1 minus x. And then I graphed it, and so I got this picture. And so which one of those is our choice? Our intersection's over here on the right, so that does look like right there. And the solution is, and you can do that second calc 5 and hit enter 3 times, and we got x equals 0.62. It does say round to the thousandth, so there's 3 places there, and that's how we would do number 1. All right, number 2 would be the same kind of problem, and you would put it into your calculator, and I've put that here as an example. I used 0.5 instead of the 1/2. And got a picture that I could match, which was B. And then when you are asked to find the solution, you do the same thing, and it says round to the thousandth. So here we are with the x value of that intersection, and rounded to the thousandths is 3.684. Number 3 is solving symbolically, so we're back to just doing this with our equation and solving through and getting x equals 5. Number 4, same way. It does say don't forget to check, and I'm not showing the check on there, but remember, if you're checking your equations, you're plugging in the answer you got and making sure that you get a true statement at the end. So these are simply equations that you can pause and look at the work, or just look at the lecture notes and you have that. I don't think there's any problem with that. Be sure when you have something like this that you are distributing, and so that's what happened here. I subtracted 6z, which left negative 5z, and then divided by negative 5. So you end up with 48 over 5, and it does say type an integer or a simplified fraction. So you would put 48 over 5. Same kind of work for number 6 and number 7. Number 8, it just shows you a graph, and you've got two linear equations, and you're supposed to find the intersection. And so you're just interpreting the graph, and this is over at x equals 3 and up at 3. So this is 3 comma 3, that point, and the solution is just the x value, so it is x equals 3. Solve each equation. So this says the solution to f of x equals negative 1. So when y is negative 1, remember f of x is like y, so when you're at negative 1 on the y, what's the solution there? That x value is negative 3. When y is 0, you're here, and the x value is negative 2. When the y value is 2, you're at 0 on the x-axis. So that's how you're doing those. Approximately 4.6% of all cancer cases diagnosed in a particular year were skin cancer. If X cases of cancer were diagnosed, how many cases of these were skin cancer? So when it says use integers and decimals, 4.6%, and write it as 0.046x, that would be that one. And then it says there were 71,000 diagnosed in that year. Find the total number of cancer cases. So 0.046x equals 71,000. Divide 0.046 over here, and you get x equals this number. And it says round to the nearest thousand. So you're looking at this digit and rounding, and you would round down because you're not at 5 here. So that's why the answer would be 1,543,000. All right. In 1981, the population density of a country was 59 people per square mile, and in 2001, it was 75 people. So it's kind of like that other problem we had. So if 1981 was 59 and 2001 was 25. But we don't want to use the years. We let 0 be 81, and then 2001 was 20 years after that. So here's your 2 points, 0, 59, and 20, 75. So if we find the slope for that, y minus y over x minus x, and that gives us 4/5. And then we use one of our points, y minus 59 equals 4/5 x minus 0. So we have this line. That's the equation. And you can see I put that equation in y1. Why do I have 89? The question says the population density will reach 89 people in the year. So the years were x values. They're giving us a y value. So when you go to your calculator, 89 will go in y2, and your equation you found will go in y1. Then you're finding the intersection of that 89. Here's y equals 89. That's the horizontal line right here. That's that one. And here's our line that we created. Now, you're going to have to change your window. If your y-intercept, if you're looking at y2 to be 89, then your y max is going to have to be bigger than 89. And see that I made it 95 just to get it big enough. And you may have to change your x max to be over far enough to see this intersection. When you find the intersection, it's 37.5. Or you could just set the two equal to each other, y1 equal to y2, and solve it symbolically like that. All right, so 37.5 is one of these. And so it's that many years after 1981. So 1981 plus 37.5 gives us 2018.5. And did it say to round to the nearest whole year? Yeah, nearest whole number. So that would be 2019. And that is the set of problems for 2.2.